Hello and welcome to this tutorial on understanding a database schema. My name is Barry Williams. I'm a principal consultant with Database Answers. Let's start by establishing that a database schema can also be called a database design, a database diagram, or a data model. It's simply a diagram showing the tables or entities in the schema and the relationships between them. What you will learn in this tutorial includes how to understand the database schema, how a schema relates to the real world, and how a schema is built up step by step. The approach that we have adopted is to use two real-world scenarios. The first of these involves going into a coffee shop, placing an order, making payment, and taking delivery. From this simple scenario in a coffee shop, we'll progress to the second one, which is a more complex situation of buying a book from an online bookstore. In the course of this tutorial, I'll be explaining some very important basic concepts, and once you're familiar with these concepts, you'll be able to understand any database schema that you might look at, even if it's defined in a different notation. Now, these basic concepts include primary and foreign keys, one-to-many and many-to-many relationships, inheritance, and finally what's called rabbit's ears, or more formally recursive relationships. Let's begin by looking at the top-level schema that we will be examining in detail in the course of this tutorial. This diagram is an overview of our schema, and as you can see, it includes customers, deliveries, orders, products, and suppliers. We'll start by looking at a simple schema for a coffee shop and move on to a more complex one for an online bookstore. When we create a database schema, we might see many things that look like they might be in scope, but the schema itself will only include what we can call things of interest. For example, in a coffee shop, they sometimes make newspapers available free of charge. However, these are outside the scope of our study. In other words, they are not things of interest, and therefore in our database we will include only things of interest, which we can refer to simply as tables. I'd like to start by discussing some very fundamental concepts, the first one of which is a primary key. Now, every table in every database in the world has a primary key, and these are indicated in our diagram by a PK alongside the field in a table. They show the field that identifies the record uniquely, which is what makes them so important. For example, in our diagram, the product ID for a product is the unique field that tells you something about the product. The values are generally created by an auto-increment field, which is called an identity in SQL Server. These fields don't have any intrinsic meaning, and they're simply integers which are generated automatically, one after another. Foreign keys, which are indicated by FK alongside the field in a table, show a reference to the primary key for a record in another table. For example, in our diagram, the product type code in the products table is related to the product type code field in the reference products type table. In other words, there must be a record in the reference table for a valid product type to be used in the product table. We'll start in a simpler way with this diagram, which shows two entities without a relationship. Let's say we go into a coffee shop to get a coffee and something to eat, or perhaps we're doing the office coffee run and we might have with us our order on a piece of paper. When we go into the coffee shop, they don't know us as a customer. Therefore, these two things of interest, products and customer orders, are not related until we give our order. Data modelers commonly describe a database schema as an entity relationship diagram, or ERD. This word relationship is therefore very important. However, at this point, we have established the things of interest, but we haven't established a relationship between them, and we'll do that in the next slide. One of the most important concepts in a database schema is that of a one-to-many relationship. These are very common in the real world and can be read as one parent can have many children. In this diagram we can see that one product can be associated with many customer order products. The line between products and customer order products is a continuous line and not a dotted line. This means that the product ID field is a primary key in the customer order products table. A dotted line would indicate the existence of a foreign key, which we have discussed before. At the customer orders products end of the relationship, there's what's called a crow's feet symbol, which indicates the many aspect of the relationship. The little O immediately above the crow's feet shows that this is an optional relationship. In other words, not every product has an associated record in the customer orders products table. This applies, of course, to products that nobody orders. At the other end of the line, which shows the relationship, there is a small horizontal line. This means that at this end the relationship is essential. In other words, every product ID in the customer orders products table must refer to a product ID in the products table. This means that the customer cannot order a product that doesn't exist. The line showing the relationship between customer orders and customer orders products shows a short horizontal line at each end. This indicates that every order must contain at least one product as a record in the customer orders products table. It also indicates that every order ID in the customer orders products table must match an order ID in the customer orders table. In other words, it must correspond to a valid order. This concludes our tutorial. This diagram shows an overview of the database schema, showing only the names of the tables and their relationships. It shows just the names of the important things of interest. This makes this diagram very useful when we want to discuss our schema with users, developers, managers, or any other interested party. It shows that products have suppliers and can be ordered by customers and delivered to addresses. In this tutorial we looked at the design of a typical database schema, and I hope that next time you look at a schema you should be comfortable understanding it, using it, and extending it.